go here. Make this a little bigger. So it says, meter stick weighing 5 newtons is pivoted so that it can rotate around one end. So that means, just like in the previous problem now, our rotation point isn't the end, or isn't the middle of the meter stick anymore, right? Now the rotation point is right there. In the picture, it's got some weird sort of funky setup.
How is it attached to the ceiling? Like,
So,
how does it move from it?
Okay, right. Well, it's not moving, right? Okay.
No.
Okay, but there's a little ball hanging off of the meter stick, like just hanging in midair, right?
Yeah.
And then there's a string that attaches it to the ceiling right here.
Yeah.
Does that make sense?
But then doesn't, or you don't have to move it? You're not trying to move it?
No, it can like this is the point of rotation, but because it's just hanging there still, what do we know has to be true?
There's like rotational equilibrium.
Right, so that our net torque has to be equal to 0 here, because of the fact that it can rotate around that ending point, but it's not.
Okay.
Okay, so we got that, right?
Yeah.
Okay, so what are we actually looking for here?
Tension.
Okay, so we'll call that F of T for tension, right? And if we draw that in the picture, right, where is the tension force acting on the meter stick?
Down.
What is this?
Oh, that string. I think
That-
it's the other one.
Nope, this one's going to be something different.
Oh.
This string right here is acting in the upwards direction, right?
Yeah.
Okay. And so this is what we're looking for. What's D going to be in this case for that string?
So, 100
It's going to be 100, except let's change it to what?
meters, so point.
And
Oh, 1. Oh, right. I always get that.
okay, so we got that, right?
Mm-hmm.
And then we have this ball hanging off of the string, right?
Yeah.
So what does it tell us about the ball?
Mass is 0.15.
Okay, so mass is 0.15.
And it's 75 centimeters away from the pivot.
Okay, so then this distance is going to be what?
0.75.
0.75, good. And then, just like before, go out here, let's draw that in. Okay, so that's going to go like this, right?
Mm-hmm.
And it gave us a mass, but we can calculate a force out of that real quick, right?
Mm-hmm. 1.47.
Okay, so we got that. And now, is there gravity actually acting on the meter stick?
Yeah.
Yes. Is it at the pivot point, though?
No.
No, we said the gravity always acts where?
On the pivot point.
Nope.
No, in the middle.
In the middle,
Yeah.
right? So there's a gravitational force that looks like this, right?
Mm-hmm.
And it's not at the pivot point, so it's going to cause some torque. So, what does it tell you about that meter stick?
It weighs 5 newtons.
Right. And we said that weight is just a fancy word for what?
A force.
A force, right? So the actual force of gravity acting on that meter stick is 5 newtons, right? We don't have to do anything with that. So we can just label this as 5 here, right? And then, where did we say that gravity was acting on that meter stick?
In the middle.
In the middle, so what's the distance going to be here?
0.5.
Okay. Does that make sense?
Yeah.
Okay. So we're going to take torque caused by the tension plus torque caused by the hanging ball plus torque caused by gravity, and all 3 of those together have to equal 0.
Mm-hmm.
Okay? If we look at direction of rotation, right? What kind of rotation is green causing?
Clockwise.
And then what kind of direction is blue, or what kind of rotation is blue causing?
Clockwise.
Clockwise again, but then red is counterclockwise, right? So we can call that red torque negative, right?
Mm-hmm.
And then it's a matter of breaking down those formulas, right?
Mm-hmm.
So negative F of tension, D of tension, sine theta, plus F of ball, E of ball, sine theta, plus F of gravity times D of gravity, sine theta. And just like before, theta is going to be 90, right? So we can, that sine theta is just going to be 1, right? So T equals 3.6?
Yeah.
No, it is. How's that?
Yep.
That work?
Yeah.
Okay. So, as far as studying for the test goes, you should have 4 sheets. This is the first one that I handed out. The one that says intro to rotational motion, describing rotational motion. And this is all pretty much conceptual. There's a couple of pretty simple calculations, but most of it is conceptual. Answers for that sheet are posted on, where is it? Notes bar. Answers for that sheet are posted on May 6th. So now I'm going to log the answers that are posted there. Then, the second sheet I gave you looked like this. Angular mechanics problems. Picture on it. And I think we did one calculation.
Yeah, we did one.
Yeah, we did one calculation there. Those are basically just plug and chug problems. We talked about the idea that when you have all those rotational quantities, they all have the same relationship as the linear quantities because they are displacement and velocity and acceleration, just, different definition of them. So the answer to those problems you can find on May 9th, angular kinematics. Then Tuesday the 10th, we introduced torque, but then we took like a week off because we were doing Cedar Point stuff. And then we picked torque back up on Wednesday of this week. And that's this problem set, the one that had the guy bending over, yeah. And then we talked about the handle of the door, right? Why the handle of the door is on the side instead of the middle. Yeah. And then I don't know, did we do a calculation about the, did we do the, we didn't do the crane, did we?
No.
Okay. So this calculation, number 14, is kind of, basically we're just using that torque formula, right? The one that it looks, T is equal to F times D times sine of theta.
Oh, yeah.
Okay. The problems down here, 10 through 15, those just basically use this formula.
Okay.
Okay. And the answers to that are posted on Wednesday the 18th, or Thursday the 19th, you can post there too. And then the last sheet that I gave you was the one we've been working on for the past couple days, this one that says rotational equilibrium. And we didn't do any of the stuff on the back, we just kept it straight on the front, and that's what the problem on the test are going to look like that. And answers to that are posted on Friday the 20th. So as far as the quiz/test goes, 11 multiple choice questions,
Okay.
3 problems, each problem was worth 5 points. So it's 26 points.
Okay.
And we're allowed to use notes, and we're allowed to use the work in our small groups. So that will be our last one.
Oh my God. And then the final.
And then the final.